Okay, so today we're going to look at stem and leaf plots again. This time the numbers are a little different. And we're going to look at Terry Fox donations. So we just had our Terry Fox run. And we had a successful Terry Fox run at Fake Testing Village this year. Here are the classes with how much money was donated. So here's a list of the classes and their donations. And your task was to create a stem and leaf plot, show all your steps.
So first we ordered all the numbers, so we found the order of all of them.
To make it easier for us to jot down the data. And then at the back we created the stem and leaf plot. So we ordered the numbers from 0 all the way to 20, and we jot down the numbers.
And there was no number for 2, so we assumed that we had to skip it and 50 after 20.
Mm-hmm.
And for this it was it was 197, so we just did.
So you made the stem 19.
Yeah.
So this was the first time we ever had to use 3-digit numbers, right? So we looked at, they created a very nice stem and leaf plot. How many of you included the number 2, the number 5, 7, 8? Okay, so none of you did. Why did you not include those numbers? Hina?
Because those numbers are not really necessary.
They're not necessary because
None of the numbers in the chart include those numbers.
there is no data for that. Because here at the bottom, they skipped a bunch of numbers. Did anyone complete their stem and leaf plot without these numbers here? If there is no data, you don't include it. So if there is no data, you don't include it. So it's missing the 2, that's okay. Okay. So this is basic stem and leaf plot part 2, because yesterday we did it all with 2-digit numbers and we added the 3-digit numbers. So I want to focus here on this part over here. So we have our numbers here, and even though they are 3-digit numbers, the stem still includes, the stem now includes 2 digits, whereas the leaf is always 1 digit. In this case, you must keep it consistent. You can't have the leaf be 1, 2, or 3-digit. The stem can change. So the leaf needs to be consistent. Okay? So this is why we keep the leaf the same. Okay? So here's a group of grade 7s and what they did. You guys notice anything different that what they did? What do you notice they did? What did they do over here? They added something. Because it looks like they put the numbers in order just like the other group, which is exactly what I've asked you to do. Great strategy. What did they do, Alia?
They added the range.
There's range, there's the least, there's the great. Why do you think they added least and greatest? Why did you add least and greatest?
So for the range, we had to do the greatest numbers minus the lowest number. So it's going to be easier to just add the least and greatest.
And this is one of the reasons why I've asked you to order the numbers from least to greatest. Because when you're analyzing data, you look at the biggest number and the smallest number. And you try to figure out what that range is. Okay? Next lessons that we do, we're going to talk about why this is important. But you need to do this. And then, mode. What's mode? Does anyone remember what mode is? The number that comes up the most. In this case, they all come up once. So there is no mode. Median. What is median? You notice that they've done something here. If you could see it, I know I could see it from here. They've circled these 2 numbers. I wonder why. It's the middle number. And in this case, how many numbers are in the data? How many values are there?
12.
There are 12. So when there are 12 numbers in the data, you have 6 on this side, 6 on this side. So to calculate the median, you need the two middle numbers, add them, and then divide them by 2, right? We're going to review all this, or we're going to learn about this in more detail next time. So if I'm going too fast, when you watch this video after learning everything, you're going to be like, I remember. And grade 6s, when you watch this in grade 7, you're going to be like, I see why the grade 7s did this. Okay? And the mean. What's the mean? Qu'est-ce que c'est le mean? Mean. All of the numbers added together divided by the numbers in the data set, right? So in this case, add them all, divide by 12, and you get a 96.2. So if there is a class that came closest to the mean, it was Mr. Green's class with 94. His class was 94, and then 96 was the mean. Okay? These are all the things you will be doing naturally, grade 6s, when you look at data. They did it without me telling them. It's because it's natural to them now. And you will get to that point now. Okay, so that's good news, right?